Thank you, sir. Now I request Mr. P. Sendil Kumar, Treasurer, Chennai Chapter IAF, to introduce the seventh speaker of the day, Mr. Samir Kelkar, CEO and Head of R&D, Grindmasters Machines Private Limited.
Hello, Foundrymen. Ellarkum vanakkam. We have come to our last paper for today, 5th Iron Symposium. Always known, best is always preserved for last. I am privileged and happy to introduce Mr. Samir Kelkar to the authors gathering. Mr. Samir is done his mechanical engineering from IIT Bombay and he is silver medalist. And he has also done his post-graduation in mechanical engineering robotics, US Berkeley. And he has done his internship in robotics first in Fanuc, India, then worked as R&D engineer in robotics, Goodall AZ, Switzerland. Now currently Mr. Samir is holding position as CEO and R&D head of Grindmasters Machines Private Limited, India. Many of us knows this company. And he is also act as a director, EcoSoftware Environmental Solutions Private Limited. And his specializations area are management of specialized machinery businesses and technology developments in robotics finishing and super finishing process with over 15 patents. And he is a chief architect for Robo Finish Solutions range. I think it looks like we have a man who has spent his whole life for the robotics, and he will talk about Fettling automation. And I also seen his, incidentally, he's a lot of interest on the sports. I just like take 1 second to read out. He is a cricket player in Aurangabad district under 16 team in 2000. He's also done IIT Bombay team for 2002 and 2003. The interesting thing is that he has been selected as the youngest umpire in India in 1999 at this age of 15 years and 54 days. And he's also Mumbai full marathon runner in 2005. It's ranked in 114. I'm not sure. No, how many people have participated? Maybe 10,000. I'm not sure. Okay, Mr. Samir, the floor is yours. Thank you.
Good afternoon, everybody. I hope you can hear me well. Okay, good. I'm very glad to come here and present on a subject on which I work with a lot of passion since the last 10 to 12 years. I'm here to talk about robotic and machine or automatic fettling or grinding. Before I begin the subject, I'll just give a brief introduction about our company. We are based here in Maharashtra in India, and we have our operations in China and the US and Europe. Roughly 40% of our business comes from selling machines to China, and 30% of the business comes from selling machines to North America. Robotic and CNC machines for automatic finishing or the grinding of the castings have been there in the market since the last 10 to 15 years. Yeah, and different foundries have tried to use these machines to a different degrees and extent. Ferrous casting foundries have definitely found it more lucrative to use these machines rather than the non-ferrous casting foundries, and the main reason being that the ferrous castings are much harder to grind. The harder the material, the harder it is to grind. Yeah, and converting from a manual operation to a robotic operation or a CNC operation is more beneficial for harder and harder castings. That is why you see that the return on investment for a well-selected ferrous casting solution and a well-selected non-ferrous casting solution, we typically see a difference. The kind of the benefit that you would be typically getting when you are correctly selecting an application for doing an auto grinding, you can see in an example of the rotor housing, which is a 55 kilo casting. Manual grinding time of this casting is around 20 to 30 minutes. Robotic time of this casting is around 5 minutes. So that's the kind of a leap in the productivity you can get by selecting the right application for doing this. I will be speaking a lot more in detail about the right application and the right technology for doing an auto grinding in the next slides. Some of the limitations of doing an auto kind of a grinding is that it cannot be done for very low volume castings, because every casting variant, it needs some kind of a tooling, it needs some kind of a fixturing, it needs the development of a part program. So it may not be feasible for doing a very low batch quantity kind of a casting. What is the main technology in doing auto grinding? The main technology, on whether you consider a CNC machine or you consider a robotic machine, is to basically replace the low horsepower hand tools that an operator is using with higher horsepower hand tools, higher horsepower tools, which either the CNC machine or the robot can handle. So manual fettling is typically done with a hand tool that has 1 horsepower, 2 horsepower. If you have a swing frame grinder and the casting is suitable for a swing frame grinder, it may have 7 horsepower or 8 horsepower. Compared to that, in a robotic machine or a CNC machine, you can have 15 to 20 kilowatt of power, that is around 30 horsepower. The machines that we built have gone up to 50 kilowatt in power. 50 kilowatt means around 65 to 70 horsepower. That is a lot more power that automatic system can pump into the application, and that is the reason why it can do that application much faster than a man. There are certain deburring or fettling applications where you cannot use a high power like this. This might be functions like deburring of the pockets or deburring of the holes inside the casting. When you do an operation like that with the machine of course is capable of doing it. But remember that it will not be much faster than a man. For example, if you have a casting with pockets with a very light flash to deburr, the man is also using a 1 HP tool, the robot or the CNC machine is also using a 1 HP tool, then it is going to do it at the same pace as man. But if you are, for example, are doing a degating or a bumper grinding, then those are typically our operations where the machine is going to be much faster than manual operation. The reason I call this as a machine is because it is indeed a machine. In fact, in several of our customers in the US and in Mexico, where this kind of operation is called as a chip and grind operation, the machines that we have supplied have not gone in the foundry at all. They have gone as the first operation in the machine shop. The reason why they have chosen to deploy it in the machine shop is because the machine shop had the right expertise of machinists, CNC, CAM programmers, people who are used to operating a lathe, a VMC and HMC. So they have been very successful in deploying these machines as the first operation in the machine shop. There have been an equal number of cases in which the foundries have deployed it successfully, but those foundries have always invariably been foundries that have also had a machine shop. We also would recommend the foundries that are trying to go for auto grinding to use machinists to like operate and maintain and run these machines, and recruit machinists that have come from a background of CNC machining in order to run and to operate these machines. There are basically 3 methodologies in doing auto grinding. One methodology is where the robot holds the spindle or holds the tools and the casting is on a fixture. The second methodology is where the robot holds the casting and the tools are kept in a toolbox. And the third methodology is to have a special purpose machine with specific tools and specific motions. The limitations of the third methodology is that there is a limitation in the number of the tools. There is a limitation in the number of the motions. When you go for a CNC machine or a special purpose machine, you are restricting yourself to a 3-axis machine or a 4-axis or a 5-axis machine. Robotic systems are more flexible, have 6 axis at a minimum, and sometimes a 7th and one more axis, an 8th axis. So the robotic systems have much more versatility in how they can move. The number of the tools in a robotic system are also higher. So what this basically means is that a robotic system is able to grind more complex castings. I would like to highlight here that I am not saying that special purpose machines and CNC machines are not good machines. What I am trying to say is that they should be applied to simpler castings that can be completely grinded with 1 or 2 or 3 tools that are present on those machines. Whereas the more complex the casting, which needs multiple tools for its grinding and multiple tools for operation, they need to be done with a robotic system. We will typically see, the next slide, we will see typically the variety of operations that can be done in an auto grinding machine. You can do a de-gating operation, you can cut the risers and gates, you can do a parting line grinding operation, you can do the riser pad grinding or what we call as a bumper grinding operation, and you can do a face grinding operation. So typically a grinding machine, to do the complete variety of operations, needs between 4 and 6 tools. Some castings that are simple in shape, and I'll come to those castings in a while, need just 1 or 2 tools, and that is where the special purpose machines can be used in a good way. What are the challenges that any machine, whether it's a robotic machine or it's a CNC machine, have to consider while they are grinding ferrous castings? The castings are going to have a variation in size, and they are going to have a variation in flash level. Castings that are, say, typically 1000 millimeters in size, 250 kilos in weight, are going to have a length and width variation of 4 to 5 millimeters. Castings that are smaller in size may have a smaller variation. Castings that are bigger in size will have an even a bigger variation. So whichever technology is applied has to be able to be suitable to take care of these variations from casting to casting and take care of the variations in the flash levels. Certain castings have a heavier flash at one side, certain castings have it at a different side. So there are technologies that include the robot motion modification and force control. There are various methodologies that are used to take care of this. These methodologies actually make a casting finishing machine or a casting auto grinding machine different from a simple VMC or an HMC. These are the technologies why you cannot put a grinding wheel on a VMC and call it as a fettling machine, because a VMC would not have these key features that would be required in an auto grinding machine. Having gone through this as an introduction, I would now come to a subject that is of a lot of an interest, especially in the foundry conditions here in India, on what makes an economically viable solution in the labor conditions, in the cost conditions that we have here in India. Various technologies have been tried out over the years. There have been a lot of its experiments, and what I have tried to do is to combine together like in a slightly simplistic way, the rule of thumb on when an auto grinding system makes sense and when it does not make sense. Typically, the heavier the casting, the faster the return on investment is going to be. For the simple reason that heavier castings are harder to grind than smaller castings. So when you come to the casting size in the 50 to 500 kg range, so that's what we call as a sweet spot, where an auto grinding solution will always be much faster than manual operation and give you really huge benefits in terms of the productivity. The castings that are smaller in size, say 2 kg, 5 kg, 10 kg, whether it is a robotic machine or it is a CNC machine or it is an SPM, for very small castings, it is not likely to give the same return on investment that you will get for the larger size of the castings. This is a key factor to make a decision. So if a foundry has a variety of castings, what we recommend is normally to select the castings in the sweet spot, that is 50 kg to 500 kg, the high volume castings in that sweet spot to really get the best return on an investment. The larger castings are typically more complex, and as I have explained, it is difficult to do a CNC grinding or a special purpose machine grinding for the larger castings. Then for the small castings, for those who want to do an automatic like system for a small casting, they have to typically choose in between two types of solutions. There is a CNC solution and there is a robotic solution where the robot holds the casting. The CNC solution and the robotic solution both work for small castings. The robotic solution is more expensive. It would cost almost 2 times a CNC or an SPM solution, but it will have certain benefits, like it can sense the casting like variants, can make an adaptation and give a better part quality than the CNC solution can, has multiple tools, is more likely to do 100% of the job as compared to a special purpose machine or a CNC machine. And thirdly, one operator can handle 3 or 4 robotic machines because the robot can handle the casting by himself. Whereas in a CNC machine, an operator has to do the load unload of the castings in every cycle. So these are some of the differences between a CNC solution and a robotic solution. Now I will share some stories of the success, and this is the success like story from the smaller casting size. These castings are not weighing very heavy. It is 2 kilos, 5 kilos, 8 kilos. The machines that have been sold in this foundry belongs to a pump manufacturer, and the castings are going 100% in the pumps that are manufactured by that company. They do not have a good return on investment, but they have continued to buy 2 plus 2 plus 2 plus 2 machines, mainly because of the quality changes or improvements that they get in their own castings. Very difficult to get a return on investment on purely the labor savings on small castings like this. So small castings, we normally recommend auto grinding only if the benefits in the part quality are sufficient to justify that investment, not the return on investment in terms of the labor savings. For the labor savings, we do come to the heavier castings. Heavier castings that weigh say 50 kilos or 60 kilos, say like 80 kilos. In these machines, the cycle times, they come down from like 20 or 25 minutes to around 5 minutes. Then these machines, they start to give a very good machine return on investment and an economics. So a typically 2 to 3 year period. This kind of a machine that can do 100 kg castings does 400 to 500 tons of casting per month. That is the kind of the volume that it can cater to. Whereas the smaller machine, the one where the robot holds the casting, it can do 100, 150 tons a month. So the larger, the heavier the castings, you really start getting like into a sweet spot of getting a good volume of the tonnage of the castings out of the machine. This is a machine that is even more heavier. This is a machine that does the cylinder heads and cylinder blocks. Foundries that are using the machine for the cylinder head application or the cylinder block application have typically used to have some kind of a snagging machine before for doing the cubing operation, and then were planning to use the robotic like system for only doing the deburring that the snagging machine it could not do. But the part quality which a robotic machine is generating is far, far, far better than a snagging machine generates. This is the reason why today the cylinder blocks and cylinder heads in this foundry are 100% grinded by the robotic machine, and the snagging machine has been taken out of the production. Typically for cylinder blocks or cylinder heads that are 100 kg, 150 kg, having the cycle times of 200 seconds, 240 seconds is a very good and a very fast result. There are multiple machines that we have built for this kind of an application in the cylinder head and cylinder block. Next, I will come to some specific applications for which a special purpose machine or a CNC machine can work out well. One of those applications is the round components like the brake drums, the brake discs, hubs. This is a category of components that has typically a parting line on the periphery and a parting line on the top face. So this is typically a kind of component for which a special purpose machine with a 3-axis or a 4-axis can really do this job in a good time, in a good way compared to a robotic system. So this is typically a machine that will grind these castings. Like for example, a brake disc is grinded in around 15 to 30 seconds depending on the flash level. A brake drum, which is a heavier casting around 50 kgs or 60 kgs, is being grinded in around 60 to 75 seconds. So certain applications like this, certain like geometries of components can be done by using a special purpose machine. One more component for which a special purpose machine can be really used well is a camshaft. A camshaft is made in very high volumes, has a parting line on the periphery and on the two sides. So it is a relatively a simple component to do the fettling of, and a special purpose machine with a single wheel is able to do a good job with a casting like a camshaft. Machines that are doing this kind of an auto grinding are here to transform the foundry and to change the human lives in the foundry. We have spoken in the morning substantially about how to get the talent and to retain the talent in the foundry. I think fettling is one of those operations which is very difficult to find people for. Though many foundries are still finding the people for doing these applications, maybe by getting the migrant labor from whichever states they come from. But sooner or later this has to change, and the foundries that will start to move towards this change now will be in a good position in a few years by learning the technologies and so on. So the foundries that are trying to move towards an auto grinding have to go with a long-term vision, have to build an expertise in the machining and the programming. So for those foundries that are not having machine shop expertise, they will have to start building machining expertise in order to deploy this kind of an auto grinding. Getting to know and understand the selection of technology, the choices that are available, and the limitations and the capabilities of each one of them. As I have explained, robotic systems or CNC systems, SPM systems, each have its pros and cons. So selecting the right technology for the castings that are being produced by the foundry is a key part of this. And then of course to work on some of the conditions for the castings that are produced, for example the flash levels. I would like to go back to one of the case studies where I'll take this rotor housing, and we had proved this machine at the foundry site with a cycle time of around 320 seconds. Yeah, and the flash levels that were present on this casting was really heavy. The root thickness of the flash was 7 millimeters or 8 millimeters. I mean, you can't even call it a flash. It's a material flow, yeah, like a bumper that has to be grinded. This foundry has really worked on its tooling and how the castings are produced, and they have been able to reduce the cycle time from 320 seconds to 180 seconds by reducing the thickness of the flash that is coming in on their castings. So there have been case studies and examples like this where the same machine has been made to deliver more tonnage, more castings by working on the castings molding process and the gating process of the castings. Lastly, I would like to highlight here a few things that we have achieved in the last couple of years. So in 2020, we did a unique collaboration with Robert Sinto Corporation in the North America. Morning session we have spoken about a few of the collaborations. I would like to highlight that in this collaboration, the technology, the RoboFinish technology that we have developed has been licensed to Robert Sinto Corporation in North America, and we get a technology fee for every machine that they produced with our designs. This collaboration has been in an activity for 2 years now, and we have built over 5 machines. 5 projects have been completed under this collaboration. Yeah, and we are looking to build many more machines under this collaboration for the North American market in the coming years. I would also like to highlight here that the last month we have launched a machine for very large castings. These are mining industry castings that weigh around 4 to 5 tons and have a 3 meter to a 3.5 meter diameter. These are very hard, nickel hard and white iron castings that are being grinded on this machine. And this machine was developed for a global foundry. The first machine has gone to a foundry in Canada, and it has been developed with technologies that were built over a 3 to 4 year period over the research and development, and has around 5 patents that have been filed in the development of this machine. So we are very proud to say that we are the world's only company that has been able to do this kind of a large casting in the mining like industry. Over the last few years, we have worked with a number of the foundries in the domestic market here in India and as well as the global market. There are different conditions, economic conditions, different conditions in terms of the size of the casting, the part variants. With this vast experience, we are able to determine which is the correct solution, whether it is a robotic solution or it's a CNC solution or an SPM solution for every application that we get in front of us. So with that, I would like to finish my short presentation. I have not shown any of the videos today, though most of the videos are on our YouTube channel, and we have machine videos for the robotic machines, there are videos for the special purpose machines and so on. Thank you.
Thank you for the lovely speech. The floor is open for questions.
Sir, you were talking about the fettling involves so many activities. You were talking about only flash grinding. But what about shifting, hammering, example? Will it do all those things?
Yes. So for example, if the flash is very heavy, we would, so if the flash is very heavy and very thin, then we would first cut it with a saw and then we would do the grinding. So chipping, hammering can be replaced with an automatic grinding function. riser and gate cutting can also be replaced with a robotic or an automatic riser and gate cutting, as I've explained. The only limitation in that is that the casting needs to be free of the sand. So to do a de-gating and a riser cutting or a gate cutting, you need to have the casting short blasted along with the risers and gates.
Thank you, sir. Any other questions? All right. So one thing is, we have to say the symposium was a good start when the right questions were raised in the morning. But I would say the symposium has got a great finish when the right questions have got great answers. The question raised in the morning from our guest of honor was saying that we are having issues with problems with workers and local workers not available. And then at the end of the session, we have an answer for one of our processes, if not all, saying that we will be able to cover up some of our problems using automation, and which is the way forward. So thank you so much, sir, for this valuable presentation and your time. Now this brings us to the close of the 5th edition of Iron Symposium. Now we will be moving on to our next agenda, the chapter cast competition. We request the audience to stay seated as we proceed. Now I welcome Mr. Saktivel Tirunavakarasu, chapter chairman, to welcome the gathering for the chapter quiz. So we would like to call upon Mr. Kiran Kumar, AGM Production, Dan Block, Brakes India Private Limited, to felicitate Mr. Samir Kelkar with an Angavastram. Now I call upon Mr. R.S. Kumar, Council Member, Chennai Chapter, to felicitate Mr. Samir Kelkar with a memento.
The close of the 5th edition of the Iron Symposium, we'd like to take this opportunity to thank all our speakers right from the morning. So I'm sure you'll all agree that the papers had great content. You had a lot of takeaways. We had some papers where there were a lot of questions, which are evidence that the papers were very good. So thanks so much for registering as delegates for our Iron Symposium and making the event a grand success. As our MC Siddharth said, we'll be going ahead with the quiz competition of the chapter level, which will be conducted by Nadimuthu sir. So thank you so much for attending the Iron Symposium. Thank you.